Hello students, after a short break we are again meeting for the numericals of this chapter motion. Now in this video we are going to discuss, already we have done the theory part of chapter 8 motion. Now we are going to do the numericals. Now for doing the numericals you cannot just sit back and relax yourself. You have to take a book and pen so that along with the video presentation, that is along with each slide, the numericals will come and that you have to write it down in your notebook. So it will be a practice for you, just as in the classroom you write it down, same manner please take a book and pen and then start doing the numericals. Now the first few slides are I'm just making you familiar with the symbols of physical quantities and their SI units. Then I will give you the formula, which formula we are going to use in this whole chapter for solving numericals. I'll give the list of formula. Then I'll also help you out with some hints for solving the numericals. So these will be the first few slides, and then we will actually start with the numericals that is given in your NCERT textbook. Okay students, so now we will get started. This slide I have just again for just recapitulating what we have done already in the previous video, that is the symbol and SI unit of different physical quantity is given. Again we will just go through that. So that is, first is distance and displacement, they're denoted by S. I already told you it is derived from a Latin word spatio, and its SI unit is meter, both of them. Next is speed and velocity, denoted by V. Its SI unit is meter per second. Then final velocity, again denoted by V only, SI unit meter per second. Initial velocity, denoted by U, and its SI unit is meter per second. Acceleration, denoted by A, its SI unit is meter per second square. Time, SI unit second, and it is denoted by T. So these are the SI units of different physical quantities and the symbol how they are denoted. These are the physical quantities discussed in this chapter. Now next we are going to see the formula for solving numericals. First one is distance. Distance, it is very simple formula. You have to just add the length, total length of an object covering the distance, that is for straight line. Like if, for example, if I say from point A to B it's 10 kilometer, point B to C 20 kilometer, C to D 30 kilometer, and then I ask you to calculate what is the distance from A to D. Simple, you just have to add 10 plus 20 plus 30, that gives you 60 kilometers. So that will be the answer for distance. You just have to add the total length, but this is only for straight line, when an object is moving in a straight line. Now if it is for a circular path, then you have to calculate the distance by using the circumference of circle, and the formula for that is 2 pi r. So if I tell you to calculate distance for a circular path, you have to use this formula, 2 pi r. So this is all for distance. Next is displacement. Displacement, it is just basically the length of the straight line from the initial position to final position covered by an object. That means there is no particular formula. You are not going to add like in distance as you have done. It's nothing like adding or circular paths. If it is completing, then you will use circumference. It is entirely different from distance. Displacement, you have to see the initial position and final position. Joining initial and final position, what is the length of the straight line, that is your displacement. Now we have already discussed displacement calculated in different manners in our previous videos, so I hope you have an idea of how to calculate displacement. Next is average speed. Here speed, or we say average speed, it's both connected to each other. Speed is distance upon time. Average speed is total distance upon total time. Okay, so over here you have to calculate the distance might be given in different like A to B and B to C, and then time will be given for that A to B and B to C point, how much time you have covered. But then if I ask you average speed, you have to add the distance, add the time, and then you have to divide it. That is total distance upon total time. That is your average speed formula. So this will come in your numerical. So that's why I'm making you write this formula. Next you have average velocity, same manner, total displacement upon total time. Okay. Then comes acceleration formula, that is v minus u upon t, change in velocity upon time taken. This is the acceleration formula. Then you have the three equations of motion, which we have in the last video, the theory part, we have done this equations of motion. It's a very important formula, because in other chapters also we are going to use these equations of motion. So please remember these equations of motion. The first equation of motion is v equals to u plus at. Second equation of motion is s equals to ut plus half at squared. Third equation of motion, 2as equals to v square minus u square. So these are the three equations of motion. Now all these formulas you have to remember for the remaining chapters also. Lastly, for circular motion, if I have to calculate the speed, I will use the formula 2 pi r upon t. So these are the different formula for solving the numericals in this chapter. But as I said, please remember these equations of motion, because it will be coming in your remaining chapters of physics also. Now there are some hints for solving the numericals. Like it will not be given directly the numbers, but you have to assume something from some phrases of the sentences. Okay. Now if in your numerical it comes a car moving starting from rest attains a velocity of 20 km per hour. Okay, now in this numericals you have now onwards two velocities, initial velocity and final velocity. Now if in the numerical it is denoted as an object starts from rest, then you have to assume that initial velocity u is 0. It will not be given u equal to 0 in the numerical, but from this phrase of sentence that I have written, when an object starts from rest, from that you have to understand that u is equals to 0. It might not be given in your question numerical u equals to 0, but that you have to assume it. Why u equals to 0 now? For example, you are starting your Activa or car. You just go on you have given just the key and you wait for the engine to heat up, right? So you're not moving. So at that time there is no velocity in your car because you are not moving. You are stationary at that position. You just started the car to heat up the engine. So at that time, when you're not moving, your velocity will be what? 0. So that is why when an object starts from rest, initial velocity u, you have to take it as 0. Okay? Next, when an object stops by applying brakes, like for an example, if I say a bus traveling at a speed of 60 km per hour the driver applies brake suddenly as child came in between the road or anything like that. So then here the initial velocity will be 100 km per hour because the bus is already traveling, and then it stops by applying brake. So when you are stopping, your final velocity, that is v, will be 0. So this you have to remember. So when in any numerical it comes like an object stops, and a car applies brakes, a bus applies brakes and stops, then you have to assume that final velocity v is 0. So this is how you have to go with this. These two things that I have given, first two hints, it is for a linear motion, that is a horizontal type motion on road when an object is moving. Now what happens for a vertical type of motion, like an object is thrown up, thrown down, then which velocity and when it will be 0, that now we are going to see. When an object is dropped down, okay, if a ball is there and it is dropped down. Now when you drop down the object, you can see when it is up, it was stationary, and then you drop it down and it attains the velocity and it moves downwards. But when you are keeping it stationary at the top, we assume that initial velocity u is 0. So whenever in any numerical it comes that a ball is dropped down, a stone is dropped down, then you have to take u, initial velocity u, as 0. Now, if an object is thrown up, then what? Then we will take final velocity v as 0. Here the final velocity v will be 0. So when you are making the object go up, it stays in the upward position for a moment and then it comes down. So we say that when you throw any object up, there is an initial velocity because you have thrown the object with your force, you have brought the object into motion with your force. So when you are throwing it, the velocity with which it goes, it will be initial velocity, and when it reaches the height and stops for a moment and then comes down. So that stopping of moment for a moment, we take that final velocity v as 0. So when an object is thrown up, it comes in your numerical, what you have to assume that final velocity v is 0. Now this also will be a common conversion that you will see in your numerical. You have to convert kilometer per hour to meter per second. Kilometer per hour is a higher unit, and if for example in a numerical it comes like this way, a bus accelerates from 60 km per hour to 100 km per hour in 10 seconds. So there you can see the time is in seconds, but I have given the speed of the bus in kilometer per hour. So when there is a higher unit and a smaller unit in the same numerical, you cannot use the numbers in a formula. You have to convert the higher unit to the smaller unit. Then only you can substitute them in a formula. Okay, so this is the common conversion you will come through in this chapter, numericals. Kilometer per hour, how to convert kilometer per hour to meter per second. Again, it is very easy. You know how much is 1 kilometer and how much is 1 hour. So this you should know that and you can easily convert it. 1 kilometer is 1000 meter. 1 hour. Now everybody, you will be giving me the answer 60 seconds, but please, that is 60 minutes. 1 kilometer is 1000 meter. 1 hour is 60 into 60, that is 3600 seconds. So when we divide them, we are getting the simplified answer as 5 upon 18 meter per second. So if I have to convert any number of kilometer per hour into meter per second, then I have to just multiply 5 upon 18. If I have to convert 50 km per hour into meter per second, I will just multiply 5 upon 18 with 50. 50 multiplied by 5 upon 18, I will get the answer in meter per second. So please remember this conversion that 1 km per hour is 5 upon 18 meter per second. Remember this conversion because we are going to use that in our numericals. So these are all the hints, formula and all the basic idea for solving the numerical of this chapter and the coming chapters. I have given it to you. Now we are going to solve the numericals. So I have taken the numericals from your textbook only, and then we will solve some extra numericals. This is the numerical in your NCERT book, science textbook, page number 100. Second question. The question is like this. A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? So this diagram was not given in your book. This diagram we are drawing, see any numerical comes, if possible draw a rough figure. So this figure is not given in the textbook, but I will recommend you that you draw the figure of any numerical that is given so that you understand and you solve the numerical. So this is the figure given of a square field. And now here one more thing, many of you might confuse yourself with the first sentence. What is the first sentence of a question? A farmer moves along the boundary of a square field. Along the boundary means I have pointed it out as A, B, C, D point. Of side 10 meter. If one side is of 10 meter, obviously as it is a square field, all the sides will be of 10 meter. And he is completing it in 40 seconds. So this 40 seconds is not the farmer moving from point A to B. Many a times the students confuse with this that only just one side moving, the farmer has taken 40 seconds. It's not like that. He is moving from point A, B, C, D and again coming back to his initial position A in 40 seconds. That means a whole one round of the square field he is completing in 40 seconds. This is the meaning of the first sentence of your question. He is completing, starting from point A, coming back to point A, he is finishing that one round in 40 seconds. Now the question is, what will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? Now displacement, I had given you the formula. It means the length of the straight line from initial position to final position. Now what is his initial position? Everyone can make it out as A. Okay, initial position of the farmer is A. But what is his final position? For that you will have to find out at the end of 2 minutes 20 seconds he is at which point. Is he at point A or point B, C or D? So we have to find that out at the end of 2 minutes 20 seconds where he will be, and then only we can calculate the displacement. So please students, you have to write down this question as suppose you have not got the textbooks and all. So please write down the question and the answer that is coming along in the next slide. Now here to find displacement, suppose A is the initial point, then which is the final point of the farmer, where he will be. To find that we need to know at which point does the farmer reaches after 2 minutes 20 seconds. He takes 40 seconds to finish one round moving along the boundary from point A to point D. Okay, so at the end of 2 minutes 20 seconds, that is at the end of 140 seconds. 2 minutes 20 seconds means 140 seconds. At the end of 140 seconds, he will be finishing off 3.5 rounds, 3.5 rounds to be precise. How we got it? It's just simple max cross multiplication also you can do. One round he is taking 40 seconds. So 140 seconds, how much round will he finish it? So we have to divide it. 140 upon 40. So we get he is completing 3.5 rounds of his square field. That means from point A, which is his initial position, if we count 3.5 rounds, he will be reaching at point C. So point C is his final position. Initial position is A, final position is C. Now from this slide, students, you don't have to write the first two sentences because it is just to explain the numerical I have written. You can start writing from the third point onwards. So now we got the initial position also and we got the final position also. Now we can calculate the displacement. So here the displacement will be a straight line joining point A and point C. So as you can see here, it has become the diagonal of a square field. Now how to find out the length of AC? That will give us the displacement of the farmer, this length of AC. Now to calculate that, you can take the right angle triangle ABC and this AC becomes the hypotenuse. So now I hope you remember the numerical that we have done already. When you have to find out the hypotenuse, which theorem we use? Correct, Pythagoras theorem. Displacement is AC. To find AC by Pythagoras theorem, we all know the formula. Hypotenuse square equals to both the sides square. So AB square plus BC square. So this is in triangle ABC. You can add that in triangle ABC by Pythagoras theorem. AC square equals to AB square plus BC square. You already know the side, how much it is measuring, that is 10 meter. AB also and BC also. So it is 10 square plus 10 square. So your answer is 100 plus 100, that is 200. So here AC square is 200, but AC will be how much? Under root of 200, because AC square is 200 and I need only AC. I don't need AC square, just AC. So AC equals to under root of 200, which gives us 10 root 2. Now you can stop your answer over here as 10 root 2 because root 2 is an irrational number, and if you know how to find out the square root, it's well and good. Otherwise, you can stop your answer over here 10 root 2. Otherwise, if you know the answer of root 2, what is the answer for root 2? If you know that, you can move further as I have done. 10 into root 2, the answer is 1.4141, like that way it goes on. But I have just taken 3 decimal places. So when you multiply with 10, I get the final answer as 14.14 meter. So it is entirely on your side that if you want to do till 14.14, if in the test or exam you write only till 10 root 2 also, you will get the marks. Okay, so this was your first numerical from the NCERT textbook, page number 100. Now we will move on to the next numerical.
Thank you, students. Thank you very much.